All right, welcome. Can you hear me over the music, over the sound? I need to figure out what the right levels are. Oh, you can't hear me? That's good. Excellent. All right, let's go and get on Kahoot. We'll do some review today. We got some interesting questions ahead of us. This will cover everything, pretty much getting you ready for the eventual final. Now, of course, this stuff is not on the AP1 test this year, but if you're taking the AP2 test, it will be. If you're taking the SAT2 physics test over the summer, you're going to need to know all this stuff. And of course, if you're taking AP Physics C, you need to be masters of all this before you come in. So this is great review for your future. Seniors who don't care, I would care just so that we do, the few questions that may be on your final, you should care. So you should know everything. Continue to learn physics because you think you might going into some field, and then you might change your mind later on down the road. And not all education is created equal, right? Some are more valuable than others. Some open more windows. So study physics. It'll open more windows, more opportunities, more things for you to do down the line. And you never know how the economy changes, based on what happens in the future, right? Make sure you find essential jobs. Essential jobs are those that are, required no matter what. If you're going to be a doctor, a medical professional, yeah, that's essential. And if you want to go to med school, guess what? A quarter of your MCAT exam is physics, so make sure you learn it. All right. So we have 10 people so far. Very good. We have more people in viewers. So we have more lurkers in the view. How many should we wait for? Maybe 20? No, 15? I don't know. At this rate, let's start at 15. We'll wait for 15 people. Call your buddies, wake them up if they're sleeping. Yeah, lurkers, stop lurking, just get in. Tell your friends. Oh yeah, tournament. Yeah, cool. Let's have 16, so 5 more. We'll wait for 5 more to jump in. Your sister finally woke up in the morning, Adam, and she joined us for our honors stream today. I don't know, I think I'm gonna lower the sound just a bit. That's definitely a first, yeah. We're not getting any more. You can literally play in your... I know, right? I mean, school has become so easy that you can literally roll over, turn on your laptop, and get on. I'm not a gamer says you can literally play in your bed, stop lurking. Now she only had 10 VODs to go. Oh gosh. So she hasn't done anything for the last 2 weeks. Alright, we got our 12th. Very good. Just a couple more. Stop lurking. Hurry up and get in. Yeah. 4 more. Let's do 4 more. Come on. I'm guessing these lurkers that are here in the viewer count are just going to watch the VOD and participate on their own. Be a part of it. Yeah. So tomorrow, as you know, we'll take our test. No stream tomorrow. It'll just be a longer version of our quiz, not really a test. Do we need a piece of scratch paper and a calculator? Yes. Piece of scratch paper and calculator. So it's like a long quiz, more like a quest rather than a test. But treat it like one. Treat it like a quiz where you get nothing and you're on your own. No talking, no closing the browser. Once you start, that's it. Make sure you're not talking to anyone, etc. You want to simulate the optimum testing environment, of course. Is this it? Is this all we're getting today? 12? That 12 measly AP1 students? Might have to... small by mighty, yeah. Yeah, maybe I'll take these names down for future reference, so I'll remember these are the students who got up early in the morning. No, it is, I think the school blocks Twitch, which is unfortunate. The school was very slow moving and unprogressive in adapting to the environment, let's just put it that way. I think we're gonna have to start with 12. I don't think we're getting any more. The code will always be there at the bottom, so if you're just waking up, go ahead and sign in. Let's go and get started. There is a delay. So this is the challenge of playing Kahoot over stream, is that there is a delay. You want to answer before it hits 10 seconds. Answer before 10. That way you leave yourself some time, bank time, because there is a delay, therefore it will close down and you're trying to answer. Right? So don't look at the time clock as it is, but make sure you give yourself a 10-second buffer. Answer before 10 seconds is up. Alright, let us begin. Whoa, look at this free picture for the free version of Kahoot. We start off with some easy ones, some morale boosters. In a series circuit, voltage Oh, time's running out. You have like 10 seconds left. Mine has already started. What do you mean? What do you mean? And now it is set times up. Yeah. So basically, it might, but you won't be able to answer because on my clock, that's how the servers are run, based on my clock. So even though your stream says you have time, or like if you're seeing that you have time, you don't. So make sure you answer before 10, just to be safe. Yes, in a series circuit. The voltage is different everywhere. It's going to be based on what the resistance is, of course. However, we know that the loop rule works, so all the voltages should add up to what the total voltage is from the battery. I joined late, but I'm in. Very cool. Very cool. So you can still you can see the code at the bottom left there, 8891132. Let's go. All right. So that was supposed to be the morale booster. Quarantine quarantine hurts me. Quarantine hurts me is in the lead. Jennifer, Emma, Marley, Maya. Who is quarantine hurts me? God. Make sure you hit the follow button. Quarantine hurts me, so you can type in chat. A metal ball hangs from the ceiling. The ball is attracted to a positively charged rod. The ball... Oh, we already have one answer, two answer. This is going fast. Okay, I don't know if you're not understanding what the delay I'm talking about. Remember, the stream, the video itself is delayed. So even though I am pressing my button where I'm sitting here, what you see is a delayed image, right? So I already pressed the button 10 seconds ago. That's why you instantly see it when you're trying to answer. However, the questions that are presenting on screen, it has almost zero. Well, it depends on your system, right? It could be anywhere from 1 second, and if you're using a phone, it can go all the way up to 9 seconds. A mixer has almost zero delay if you think about switching. Switching to mixer, no. Twitch is a much bigger platform, so we'll stick to that. All right. It could be either. It could be either. Oh man, this one got a lot of people. Right? If you're neutrally charged, remember you can polarize it. Metals can easily shift their electrons around. So if you bring a positive rod next to the metal ball, all the electrons will move to the face, and therefore the face will become negatively charged, or at least negatively polarized, and that will cause a attraction between the charged rod and the ball. So don't forget about polarization. All right. So let's see. Did anyone? Oh, Emma has taken the lead. Ayan, and then Maya. Quarantine hates me, and Jennifer. It's anyone's game. It's anyone's game. What must be done to give an object a positive charge? This is a freebie. Where are my AP chemistry students at? Or just regular chemistry. If you took regular chemistry. We need a particle accelerator, and then we'll shove a proton into your atom. Hopefully it doesn't break apart, and what must be done? Yes, you become positive by losing your negativity. All right. Oh, we did not get 100%. Yeah. Yeah. So it would be a different element altogether. Ooh, Ion is on fire. Diggity Dog has come out of nowhere. And then we have Hi. How? Is it Hail Chiba? Hail, is that you? You just forgot the E? Probably. Who picked red? No, let's not talk about who picked red. This is a safe zone. This is a work conducive. We don't want to be a hostile work environment there, Bubble Guy. Bubble guy, you're creating a hostile work environment. I need to report you to HR. All right, let's keep on rolling. Of course, you become positive by losing your electrons. All right, another freebie. This is a freebie. One half BH. What is BH? What is BH? I don't know. Hey, there it is. We got the 100. Can we get a 100 hype train in the chat? 100. Whose current isn't a triangle? It's the same everywhere and the same as the total current. If you have one path, of course the current is the same. That was a freebie. We gotta make it a little harder than that, I suppose. Thank you, Ion. You're the only one who understands. Oh, nice emoji there. How do you do that? I don't know how to do that. All right, hurry up. Let's get all these free points out so we can get to the hard questions. In a series circuit, total equivalent resistance. Rec in series. Come on now. I thought the clock is supposed to stop as soon as everyone answers. Oh, there it is. We have 13 players now, I suppose. Yeah, you just add them up. Alright, moving on. Quarantine hates me is back. I can't see all. Yeah, there. Emma is still in the lead. Example of a good insulator. Now, of course, if you want to learn more about electrochem, consider taking chemistry. Well, they'll do all sorts of cool stuff. I think, you'll get to test out different material and see what is conductive. You'll get to, I don't know, use a watermelon to light up a light bulb, or a potato, or I think they do salt bridges. They make batteries and solar cells. Put different materials in between your circuit, trying to see if it conducts electricity. Copper is my favorite insulator. Ay. Someone actually picked copper. Remember, all of your wires have copper inside. Copper. That's what you use when you plug stuff in. If you cut your wire open, you'll see there's copper in there. Graphene, your pencil, the lead that you have, you can actually use it to conduct. This is where we would do cool demos and stuff in class. Pretty clear to me. Oh god. Bubble guy with the dad jokes. So glass, plastic, those are pretty good at insulating. Of course, rubber. But copper, salt water, any ionic solution, they're pretty good conductors. So chemistry students, hydrochloric acid, HCl, will dissociate very, very nicely into positive and negative, ions, and that'll allow the electrons to flow through. Any, Powerade, Gatorade, all that stuff, can conduct. All right. So glass is no bueno. Shiraz in 5th place, coming out of Nowhere, it seems. Ionic solution. All right, easy peasy. Now your quiz tomorrow is not going to be this easy, but this is good practice, good things to remember, recall, as we go into these harder questions that are coming up. It's to good, jog your memory. The goal is to use all of this information to overcome new challenges. The electrolyte solutions, yeah, they're electrolytes. Oh, did we get more players? I think so. I think we have more than 13 now. Some people are waking up, finally. Is the same everywhere and the same as the total voltage. Yes, if I had 3 in parallel, all of them would have the same voltage, and it would have the same voltage as the battery. Just look at the nodes. The top of the resistor and the bottom of the resistors are connected to the battery. The top and bottom, I suppose. All right. We got some more shuffling going on. JH. I don't know who JH is, but welcome. Oh, is that Josh? Maybe it's Josh. I'm going to guess it's Josh. All right. When charging the electroscope by induction. Ooh, induction. Failure to ground would give the electroscope a blank. By the way, you could always go to Kahoot.com and make an account, and then you can discover and like play all the Kahoots that are made. There are like thousands upon thousands, and you can just search, circuits Kahoot, and it'll come up. There's like so many questions. Yep. Ooh. This was a tricky one. If you want to do it by induction, okay? If you want to do it by induction, remember induction involves a 4-step process, basically. First, you have to bring your charge rod close to your object, okay? And by doing that, you polarize it, and then you connect it to a wire that's grounded. This allows the excess charges to flow out into the ground. Ground means the earth. And once that happens, you can disconnect the wire, and this will leave the object charged up. But if you don't ground it, then the charges can't flow out, so it'll just remain polarized. Ooh, tricky, tricky, tricky. This one got most of you. A lot of you said negative charge. No, when the charge... Yeah. Remember, the charges will stay inside the body. If you don't ground it, there's no pathway for those charges to move, so they'll still be there. Okay. And polarization is a separation of charges. It's not really charging. It's a separation. The net charge of the object is still neutral. It's zero, whatever it was before. You're just separating it from one side to the other. All right. Let's see. Got some more shuffling. JH is on fire. Ion is in third. Diggity Dog, whoever you are, good job. Keep on going. And Jennifer rounding up the top 5. It's anyone's game. It's anyone's game. parallel circuit is different. Yeah, the current splits up based on how much resistance you have. However, your junction rule still applies, so whatever goes into the junction must be equal to what comes out of the junction, and so it adds up to the total current. Oh, we almost hit 100, not quite. We have a 14th player. 14th player. Ooh. Josh is somehow has taken the lead. I think it's Josh. If you're Josh, go ahead and say something. Or we'll just say it's Josh. It's Jocelyn. If you double the charge, that's a freebie. Here's an honors question. Oh my goodness, we were so close. It quadruples. Yes, Q times Q is 2 times 2 is 4. It is Josh H. Ah, yes. Cool. Quadruples. Quadruples. All right. Nothing shifting there. All right. Now the second half. Second half is slightly harder. Can we get a 92.8 in chat, please? 92.8? Sounds like a radio station. Alright, so in the parallel circuit, we want to know about rec. How do we do rec? It's not rec for 2 if you have multiple. It's the inverse of inverses. Yay. All added up. There's the 100. There is the 100. 100. Your Josh's streak is still going. Wow. Yeah. Uh-oh, gotta do it fast. Holy moly. Cannot be determined in 30 seconds. Alright, good. So it doesn't matter how it's going to be dropped, right? It's whatever the battery is. You don't have to guess. The battery's 24. The total is 24. Done deal. Bruh, my stream stopped loading. Time to guess. Yeah. So yeah, whatever it is, no matter how and what resistor you have in there, all of it will drop whatever the total is, and that's the battery. All right. Oh man, my foot fell asleep. I always sit all weird in my chair. I'm gonna sit properly with good posture now. Hopefully it takes care of it. Maybe I'll just start walking around. Yeah, let's try that. All right, here's question 13. Says a proton and electron are held 1 meter apart and released. Where would they meet? Can I go back and pick a different one? Ah, no, it does lock itself, so that is unfortunate. Unfortunate. Inertia is a thing. Inertia is a thing. Closer to the proton side. Yeah, the forces will be the same, but of course the proton is 2,000 times more massive. Therefore, it doesn't, accelerate as much. Therefore, it doesn't move as much. So yeah, you're both annihilated by a black hole. No, not quite. Oh man, this one got you guys. Ooh, Shiraz in 5th place. All right, Shiraz. Ah, here's another one. It says, as the electron moves in the electric field shown, which path will it take? Did someone say marble in a cup in a different world? With negative gravity, perhaps? Ah, the answer was Z, of course. Path is Z. Electrons go in the opposite, or accelerate in the opposite direction. They feel a force. F is in the opposite direction to E. So if you have E going up, then the force is downwards. So it's almost like in a uniform gravitational field where you take a parabolic trajectory. Lil salmon, yep. So it takes path Z. It's marble in a cup all over again. In the uniform electric field shown, which statement is true? Ooh. This is all about potential. When you see these things, you want to think about how to emulate them in real life. How can we make an electron or uniform electric field? Recall from your notes how to make one. Well, you can use 2 metal plates and have a parallel plate capacitor. And so this uniform electric field could be the region between 2 parallel plates. And so which one would have the higher potential? Yeah, so A and B is equal, C is lower. What you want to do is basically imagine, your parallel plate capacitor here on the left side. I need to eat breakfast. What you guys have for breakfast today? Salmon? If you imagine parallel plate capacitors, my pen's not working. There we go. Parallel plate capacitor. In order to have a uniform electric field going to the right, I need to have positive charges here, a positive plate, and a negative plate. All right. So of course, if I had a charge Q, closer to the positive plate, okay, then it's going to be forced away and it's going to move towards the negative plate. Now, if you're already in the middle, then there's not as much potential. You can flip this image around so that it looks like gravity. You just had cereal. What's your go-to cereal? If you flip it around like so, imagine this being plus, this being minus. And so if you had a Q all the way up here, of course it has more peg-maga, or in this case PEE. And a Q over here doesn't have as much peg-maga, or in this case electrical potential energy. So you can look at it that way as well. Frosted Flakes. Ooh. Just an FYI, I have 4.6K channel points. Get out of here, Jacob. Get out of here. uh, out here farming. Oh my gosh. All right. Uh, Jacob is one of the lurkers, it seems. He's farming his channel points. No, it's not. It's based on time, I believe. I don't think it's sub. All right. So, some more shuffling going on. Jennifer in third place. Excellent. We're almost done. So it says a wire's length is constant, but its radius doubles. What happens to its resistivity? I literally open stream when I wake up and go AFK. Good, good. As long as I'm getting the viewer numbers, right? That's all that matters. Sub does give me slightly more. Oh, does it? I didn't know that. Yeah, you could have gotten into the Kahoot. Slipping on banana peels here. Slipping on banana peels. You slipped on the banana peel? Yikes. It stays the same. It stays the same. Resistivity is a material property. Material property, not resistance. Resistance is resistivity times L over A. Highlight a message. Highlight you're slipped on a banana peel. Oh, you don't want to use it up? I see. I'm going to save it. Very good. Ooh. Oh, it didn't change anything? Oh, wow. Everyone stayed the same. Which either means everyone got it wrong or people who got it right are nowhere in sight. Kirchhoff. Ooh, here's some new ones. Now you really got to think. Kirchhoff's junction rule is a statement of... Everything is angular momentum, right? Oh, it's not an option. Whoa. Hold your horses there, buddy. All right, it's not a contest. Keep it to yourself. Law of conservation of charge. Yes. So imagine Kirchhoff's junction rule. That's where the current that goes in must be equal to current that comes out. Okay, it's the amount of charges that flow into a junction, into that dot, must equal whatever is coming out of the dot. So it has to be charged, not momentum. It's not energy, and it has nothing to do with the mass. Got replaced by my prime badge after a day. Huh? Here we go. All right, next up. I'm now in 11th place. Epic. Weren't you like 5th a couple of questions ago? Kerkoff's loop rule is a statement. Alright, loop rule. When we go around a loop, the sum of all voltages equal to 0. What could that be? Definitely momentum, right? There you go. If you did your mastering physics. Conservation of velocity. The law of conservation of energy. Energy, yes. So just imagine the battery boosting you up to the top floor, and then as you go down each resistor, you're going downstairs, and each time you go down a staircase, you're losing some of your electrical potential energy, because that resistor is turning your electrical potential energy into heat. I slipped on too many banana peels. Oh, there's a quote from Slazer, and he used the banana emoji. All right. Any shuffling? There are some shuffling. Hey, Quarantine Hates Me is back. Marley in 5th place. Welcome, Marley. Alright, let's finish it up. We're almost done. Here's the penultimate question. The current through the ammeter is 20 milliamps. What is the current through the 40 ohm resistor? Ooh. Hint, do a current flow diagram. Current flow diagram. You want to use your strategies, all the things you've learned, how to solve problems, and apply them to new situations. So do a current flow diagram. How is the current flowing in the system? Ammeters don't actually use up anything. They just tell you what it is. It's a reading. It's a device that measures current. Very good. It is the same as whatever's at the top. Yeah. So that 20 milliamps split up into, some of it goes into the 15, some of it goes into 30, right? It's a 1/3, 2/3 split. And then it recombines again, of course, it recombines again, and then all of it goes through the 40. I read the wrong number. Ouch. All right, so here is the last question. Let's see if we had some shuffling. Ooh, Marley in orange, whoever you are, excellent. You are now in 5th place. Shout out to Orange. Orange. All right. Here we go for all the marbles. Here's a side note. The voltmeter is in parallel with R. That's because voltmeters need to be parallel because parallel things have the same voltage. So the voltmeter can read the same voltage as whatever R is. And it says the voltage is 1 volt across R. Okay, strategy. What strategy should we do? Well, when we analyze circuits, we should always do Kirchhoff's loop rules. So do a loop rule. Ooh, of course I saved the best for last, it seems. And time is running out, and wow! Okay, so let's go back to the drawing board on this one and see how we can analyze this circuit. Let's open up OneNote. Okay, so we have, what do we have? We have some sort of battery, right? Was it 3 volts? Yeah, 3 volts. 3. We have a 20 here. R. And then we have another 20. What do we have on the side here? Well, we have a ammeter. The ammeter says it's 20 milliamps. 20 milliamps is 0.02 amps. We have a 15, a 30, and a 40. Of course, we can see how these two, the 15 and the 30, are parallel, and then in series with the 40. You could simplify it if you want. Let's go and do it just because it's fun. 3 volts. We have a 20 R 20. And on the side, we have the combination. What is the combination? We have the 15 and the 30 are parallel and in series with the 40. What is 15 and 15? Well, 15 times 30 divide, 15 and 30. 15 times 30 over 15 plus 30. That's 10 plus the 40. So this gives us 50. All right, so anyway, we don't really need that, but it's nice. It simplifies things. Okay, we know that the current that is going here from this junction is 0.02 amps. Okay, we also know that the voltage drop that happens here is 1 volt. Right, so let's go and do a loop rule. So if I go through this, go through here, go through here, well, let's do red, 3 volt, let's call this resistor 1, resistor R, resistor 2, and this is resistor 3. 3 minus V1 minus V at resistor R, well, let's just call it 1. 1 minus V2 is equal to 0, right? So this means that 3 minus 1, which is 2. 2 must equal V1 plus V2. The voltage drop that happens at the 20 ohm and the 20 ohm, well, they're both 20, so it must be the same. V1 must equal V2 because they accept the total current. Notice how I1 is the total current, and I2 is also the total current as it returns to the bottom of the battery. Therefore, it must be 1 volt. All right. So, so if I know that this is 1 volt, how much current goes into this junction? Okay, well, so I1 must equal V1 over R1, and that's 20, that's 1 volt over 20 ohms, and 1/20th, that's 5%, or 0.05 amps. Okay, so here we have a junction. We have 0.05 amps going into the junction, and then 0.02 amps coming out of the junction, and then some other amperage going out. So what's the leftover? How much is coming out? All right, very good. It is 0.03 amps. So that means 0.03 amps is going through this resistor. And finally, just use Ohm's law. V is equal to IR, so R is equal to V at R divided by the current at R. The voltage at R is 1 volt. The current at R is 0.03 amps. And this gives us the 33 equals happy face. Alrighty then. Third place goes to Quarantine Hates Me. Oh, you guys can't see. There we go. Second place goes to Emma. And first place, Josh keeps it. And runners up, Marley in fourth, and Orange, whoever you are in fifth place. Alright, well, thank you for playing. I'll see you next time.